Okay, some information about me. Daniel Scott, as I mentioned. I started my fire service career in England, and after several years there, I decided to move with my family to Sweden. And during that time, I worked for 2 fire services in the Stockholm area. And about 14 years ago, I was given the chance to go on a Cobra instructor's course, as we had Cobra on the station. And I thought it was a fantastic tool. Ever since then, I've been very interested in it. And particularly, I think the areas around firefighter safety are very, very important and something that needs to be developed. My main interest at coldcut systems, where I started about 2.5 years ago, is to run the instructor courses. We do these mainly in Sweden, but we do occasional courses out in Europe, and that's something that we want to develop. We would like to have a school in every country in Europe eventually. The other thing I work with is method development. Over the past 20 years, the areas in which Cobra is being used have increased enormously, and what we would like to do is to continue that development. And make these methods as effective and efficient as possible. It's my colleague, Lyanna. She can't be here today, so unfortunately you won't get to meet her, but she was a part-time firefighter in Cobra in Sweden, which is the main ski resort. And there she got an interest of fire and fire service, and so she decided to study to become a fire engineer. She started, I think, in January this year. I think we make a good team because I'm more practical, I think, but Lyanna's very good with the theory and the statistics and the facts and figures. So we work very well together. And as you saw on the social media that we sent out, what we're going to be talking about today is the safety distances when using Cobra. Now, how far can you be from it or close to it, whichever way you want to look at it? When does it become a risk, possible risk for injury? And also, we're going to be looking at a case study from Halmstad in Sweden. It was about 2 months ago, where they had quite a severe fire and used Cobra in different ways with a very successful result. The actual tests, if you've been on one of the instructor courses, you'll probably recognise this picture. And this is what we've been teaching for many years. And what you can see at the top, everyone that's going to be in and around the Cobra when it's used should have full PPE. And then within 5 meters, you should definitely be having some sort of eye protection on, because there is a risk that the abrasive from the Cobra may bounce back and hit you in the eye, or even parts of the building that you're shooting through. You could get bits of wood or brick or other things. And then what we've said is 10 meters in front of the lance. And this is the distance which I think has it's resulted in a lot of fire services and firefighters being very reluctant to use Cobra at the same time that BA wearers are in the building. And so I wanted to test this because 10 meters is quite a long distance. And what the 10 meters it comes from is it's a general rule within the water jet industry. It's nothing that's specific to Cobra. So we wanted to test this and be able to work with facts rather than just a general rule. And this picture as well, we always show this one. This is the PPE that's required, full PPE from your head to your toes. So jacket, trousers, boots, gloves, and most importantly, the helmet with an absolute minimum is glasses, but we recommend a visor because that provides better protection against the water and the abrasive, possibly causing injury to your eyes. When we did the test, we worked with a company called TST. They're about an hour away from us in Sweden. They work with the water jet industry. The water jet that you can see on the picture, that works at 3,000 bar. Cobra works at 300 bar, so it's 10 times the pressure. So they're very experienced in this area. They don't actually make the water jets, but they make the PPE. So everything you can see on the picture, the helmets, the clothing, the gloves, the boots, and then they make other products as well. Every time they produce a new product, then it needs to be tested up to 3,000 bar. So they've done similar tests hundreds of times. So we thought they were the right people to work with. They know exactly what they're talking about. So what we decided to do was test Firefighter clothing, which you can see on the left. It's a well-known make. I'm sure some of you have got it on the fire station where you are now. And also a well-known make of mask, breathing apparatus equipment. And we wanted to see how well they would withstand the water jet from Cobra, and how close could you come without having a risk for injury. We decided to work only with water and abrasive because that's really the worst case scenario. The water and the abrasive have a much greater cutting capacity than just water. So all the tests are with water and abrasive. And these were the tests that we did. So as you can see, if we start with the right-hand picture, so this is the testing rig that they always use. And the Cobra at the top, you can see the blue hose, and then the nozzle is attached to the stand. We used the manual operation, so we operated the Cobra from the vehicle. Directly under the nozzle, you'll see a box with a piece of the yellow cloth from the PPE in it. And what will happen is that when we operate the Cobra for a few seconds to build up the pressure, and when it's up to full pressure, then the trolley will move underneath the water jet. TST advised that they never do static tests, and that means firing at a certain point for a number of seconds, because they said it's not realistic. Because in reality, either the lance is moving or the person is moving, so they always do this sweep test, as they call it. And the trolley will move underneath the water jet at a speed of 0.5 meter per second. So what we'll see now is the video on the left-hand side. So the woman in the orange PPE, she's operating the trolley. You can't see me, I'm by the vehicle. I'm operating the Cobra. So you'll see the water jet start. After a few seconds, when it's up to full pressure, then she will move the trolley underneath the water jet. Here it comes. There we are. So we're going to start the water. Water started. 2 seconds to get it up to full pressure. And now she's going to move the trolley. There we are. So what she's done there is we've simulated a sweep of a lance against some clothing. And what do you think the result would be? I was quite surprised when I saw it. Here's the result. So 93 centimeters from now, I'll just say 1 meter, just to make it easier. So what we saw with the water and abrasive, it cut through the material, which was in 3 different layers, which you can see, the yellow, the white and the blue. And underneath that was 2 layers of foam, and it cut through everything. It was quite surprising. It gave me a great respect for the Cobra. It's nothing that should be used lightly, and you need to be careful with it. So that was the result of the 1 meter test with water and abrasive. As 1 meter, that was the maximum height of the testing rig. So we needed to think how we could find this distance where it would become safe. So we did some adjustments, and if you look at the left-hand picture, you can see the nozzle to the far left is now attached to the trolley, and that enabled us to shoot in a horizontal direction instead, and we attached the jacket to like a doll on the forklift truck. We started at 5 meters, inspected the clothing each time, and then moved in a meter. And what we found was that 5 meters, there was no damage at all. It didn't go through the clothes. 4 meters, the same result, until we came down to 2 meters. This is a film just to show you how the test worked. So we have the test rig over here with the nozzle. The trolley will move in a direction, and it will go across the clothing just by the blue strap here. So the water jet has started. It takes a while to get up to full pressure, and now it's going to sweep across the clothing. I think this one was 4 meters. And everyone in the background, they were further away than 5 meters, and they've all got glasses on, if you're wondering. So the tests worked. And this was the result from 2 meters. So we've gone from 5 to 4 to 3 to 2 meters. And what you'll notice here on the left-hand picture, and this is what they said to us, was that the reflex material is always the weakest point on this type of clothing. You can see halfway up the picture here, we can see that there's some marks, some have started to appear, and also just here, very, very faintly, you can see the start of damage, and there's some abrasive stuck into the jacket. But on the inside, there's no penetration at all. Nothing on the t-shirt and nothing on the doll underneath. We decided to use just a t-shirt. A lot of fire service have a thick jumper on at the top. This is where we decided to stop the test, because once it starts to damage the clothing, then we decided that between anything close than 2 meters, that would start to cause a greater risk. So we decided to stop there. And this was the mask at 2 meters. And I was very impressed with the mask. There was virtually no damage at all. You can't even see it on the picture. There was very, very slight scratching from the abrasive. But otherwise no damage, and absolutely no penetration of water or abrasive. So the conclusions of these tests, what are they? So up to 1 meter, the cutting effect of the Cobra is very, very effective. As you know, it will go through just about any building material. But quite quickly after that, it will start to break up, and as close as 2 meters, there wouldn't have been any injury to the person if they were wearing the jacket that we just saw. And really, that's exactly what we want. Close to the nozzle, we want it to be very effective at cutting, but we want the jet to break up as soon as possible after it's cut through the wall of the house, to create a spray which is very effective at cooling the fire and cooling the fire gases and possibly extinguishing the fire. So these results we were very, very pleased with. Effective at cutting, effective at cooling the fire. And so back to this picture. So if we're looking specifically at Cobra, the 10 meters seems a bit too far, but I would like to split this into 2 situations. If you're training or if you're testing Cobra, say at the fire station, I think absolutely 10 meters is a good distance to use, because there you have the possibility of someone without PPE walking in front of the lance. If you're testing it out the front of the fire station, or if you're using a cutting exercise at the fire station. So then definitely I think you should stick to this 10 meters in front of the lance. So that's the non-operation. But if we're talking about operational, then we're in front of the lance, then we're talking about people with full PPE on, with a mask and with the breathing apparatus. So I think this 10 meters is possibly a bit too much, and we can reduce that. And when we reduce it, it gives us the possibility to develop our methods and tactics with the Cobra. I'm going to do a drawing on the board and discuss what this development of method actually means. Okay, now we're going to talk about how the safety distances, the facts and figures that we've just presented to you, how they can affect method development, and in particular using Cobra at the same times that we have BA crews in a building. What I want to start with is saying what we're not suggesting is sending in BA crews and then just randomly using the Cobra through the walls of the building, because obviously that's very dangerous and there is a risk of injury. What we're talking about is a structured approach, and there's three things which I think are key to this being a success. The first one is training, well-trained BA crews, well-trained Cobra operators. If everyone knows how the BA work, how the Cobra operates, what it can do, what it can't do, it shouldn't be a problem. The other thing is, the second thing is effective command and control, structured approach, no one makes their own decisions. And the third thing is communication, probably the most important one. If we communicate, everyone knows what's going on, we're going to greatly reduce the risk of problems. Now, I'm good at certain things. Drawing isn't one of them, but this is a drawing of an incident that happened in Gothenburg a couple of months ago. In Gothenburg, they've had Cobra for a number of years. They've worked hard to develop their methods, their tactics, and also their training. And they've had some very, very good results, and this was one of them. And this is a perfect example of how we can use Cobra and BA crews at the same time with no risk to the crews. So we had an attic fire in an apartment block, and the officer in charge, the first order that was given was with the high-rise appliance to get the Cobra to work into the attic to cool the fire gases with water mist, and because it's an enclosed fire, possibly even extinguish it. So we're having a positive effect on the fire. At the same time, the BA crews can lay out their hose up the stairs, given a very clear order, get to the top of the stairs, wait underneath the attic. When the officer is satisfied with the effect that the Cobra has achieved, we stop the Cobra. We then give the information to the BA crews, the Cobra is stopped, you can now enter the attic to go up and look for any small fires which may be remaining. So when the Cobra was in use, there was absolutely no danger to the crews because they were a long distance away. There's no chance of it penetrating the roof and injuring them. And this is what was the result of the fires. As I said, Stockholm have worked very hard on training their Cobra operators, their BA crews. They have effective command and control. and they have very good communication. Everyone knew when the Cobra was in operation, everyone knew when it stopped, everyone knew when it was safe for the BA crews to go up into the attic. But we had a very successful incident. Cobra and the BA crews were operating at the same time, and there was never any risk of injury from the Cobra whatsoever. So a very successful incident from Gothenburg. We could use other examples. We could say Cobra is being used on a fire in the basement, and the BA crews are searching the first and the second floor. As long as they don't go down the stairs into the basement, there's never going to be any risk that they're going to be injured. We could have a building with a central corridor. The Cobra is used on the left side in the workshop. The BA crews are searching to the right in the offices. As long as they don't go across the corridor into the workshop, it's not a problem. And what I would say as well is that the Cobra has a very distinctive sound. It's quite loud. So even if they did go over the corridor and open the door by mistake, they would hear very soon that what was happening, and they would be able to close the door and back out. So just to summarize again, well-trained firefighters in Cobra and BA, effective command and control, and effective communication. It shouldn't be a problem to have BA crews and Cobra working at the same time. We're not going to be able to answer all the questions today, solve all the issues and problems around this. That's something that you need to do yourself as an organisation. But if you need any help with that, contact us and we'll be glad to help you. And this picture here, this is probably the most important picture, because we've done these tests, we've presented the facts that we found, and we found that as close as 2 meters to the lance, there isn't a great there isn't a great risk for injury. But having said that, all fire services are unique. You all have your own equipment, you all have your own control and command systems, different training, different experiences. So what we want you to do is to take this information from this webinar and do your own risk assessment. How do you want to incorporate these facts into how you work as a fire service? We don't want to go out and say 8 meters, 6 meters, 4 meters. We want you to make that decision yourself, because you're the people that are using the product. So take the facts, incorporate them in a risk assessment, speak to your health and safety people, discuss it. How can we sort of move forward with our tactics using Cobra? Okay, that's the sort of first part over. We finished with the safety distances. Now we're going to look at this incident from Sweden. Place called, I'll have a bit of technical difficulty. Doesn't seem to work. Okay, we'll halt that. There we are. Okay, so this is the incident I was talking about in Halmstad in Sweden. It's quite clear where the fire has occurred in the building at the front. This was student accommodation. When they arrived, there was a well-developed fire, and they were told that people were missing. So the number one priority was to enter the building, search it and to try and fight the fire at the same time. After a while, they had to back out because they realised that it was developing into quite a dangerous situation. So the tactic now was to stop the fire spread to adjacent buildings. And what they did was they used Cobra in 3 different ways. And they're the 3 3 coloured arrows, which I'll talk about now. So the blue arrow, that's between the 2 buildings, and that you can see on the right-hand picture. So they had a firefighter that was standing with the Cobra, using it in a sort of a sweeping motion, and he was there for several hours, because what we know is that the very fine water mist is very effective at absorbing heat, radiated heat, from one building to another. And as you can see, the roofs, it wasn't even a meter, and the passageway, he said you could actually put your hands on each wall, so it was around about 2 meters between the walls. And even though the buildings were very close together and we had a very severe fire, the fire is burning on the left-hand building, there was no fire spread between the buildings. And that's thanks to the water mist from the Cobra. So that was the first method they used. As the fire started to spread and it started to get close to the White House at the top of the building, they decided to take another Cobra and shoot in through the wall in the direction of the red arrow to try and push the fire away, to try and keep the fire away from the White House at the top of the picture. So we had the Cobra in the blue arrow with the water mist between the building, and then we had the red arrow indicating the Cobra being shot into the building at the same time. So 2 Cobras, 120 litres of water a minute, that was very effective in keeping the fire back from spreading to the next house. What they did notice, there was no fire spread to the white, but just where the green arrow is pointing, they did notice one spot that was becoming black because it had become very hot, and they were, because it was a wooden house, they were afraid that the fire was possibly starting to spread into the house. So they took the Cobra and they pierced the house in 4 or 5 points, just very quickly around this area where it was starting to become black, just to extinguish any possible fire that was there. And the result was that the only, if you could say, damage to the damage to the White House was this small spot, and also a smell of smoke in the White House that you can see at the top of the picture. And very soon after the fire, the students could move back into their accommodation. So very intense fire, large fire. Cobra used in 3 different ways in a very effective manner. And I've spoken to the firefighters that were there, and they said that without Cobra, this result wouldn't have been possible. So it's very good for us to hear. Very successful fire. There we are. There's just a little bit more information showing what they did with the coloured arrows there. So that's the end of the webinar. We've spoken about safety distances. 10 meters, that's what we've been talking about before. We've shown that you can come as close as 2 meters without risk for injury. But once again, I would like to stress the point of you using these facts. Do your own risk assessment. You know how you work, you know your methods, you know your routines, your rules and regulations. How can you fit these facts into how you work? That's the important thing. It's up to you to decide what you do with them. Very grateful for that you listened today. This is our first webinar. We're hoping to do many more. We haven't had the opportunity to answer any questions live while the webinar being shown. So contact us on the email that you can see in front of you, and we'll be happy to answer any questions. Thank you very much. My name's Daniel Scott, and hope to see you in the near future.